So we know we can always plug in a value of the explanatory variable into the regression equation and predict the response. But how accurate is that prediction? In this video, we're going to use confidence intervals and prediction intervals to sort of judge that accuracy. And notice this is different from the confidence intervals that we've done in the past, because what we're trying to predict here is not a parameter exactly, it's just the response values. So we can make two types of predictions. One of them is using a confidence interval for the mean response to give a range of plausible values for the population mean at each specific value of x. So let's just pick a point on the x-axis, maybe total cholesterol of 180. So if we kind of imagine just like that one tiny sliver of the graph or of the population, what we would be estimating with a confidence interval is the mean of all those BMIs. So at a particular value of cholesterol, what's the mean BMI or the mean response? Another way of saying this is that the confidence interval is intended to capture the true regression line, because that's really what the regression line is telling you, is what value would we expect for each particular x? What value of the response would we expect for each value of the explanatory? So a confidence interval is intended to capture the mean. We can also do a prediction interval for an individual response. So instead of trying to capture the mean, this gives the range of plausible values for a new individual response at a specific x value. So going back to that cholesterol of 180, now we're not looking for the mean BMI, now we're looking for the whole range of BMI values at that particular x. So when you're talking about a prediction interval, the goal there is that it's intended to capture most individuals. So like if you have a 95% prediction interval, you're hoping to capture 95% of the individual data points at that x. So earlier when we talked about sampling distributions, we talked about how the means are much less variable than individuals. And so looking at this graph, this inner line here, the narrow one, that's the 95% confidence interval. Because we have a really large sample size here, so we can be pretty precise about estimating the mean. The wider one here, this would be the 95% prediction interval. So this one has to be a lot wider because we're trying to capture individuals. And if you think about it at the individual level, there's all sorts of reasons why BMI might be higher or lower that have nothing to do with cholesterol. So we've got a lot of spread in our individuals, so we need our prediction interval to be much wider than our confidence interval. So let's take a second and think about the factors that affect the width of these intervals. One of them is the sample size. So as your sample size gets bigger, what do you think happens to the confidence interval, and what do you think happens to the prediction interval? The other one is R squared. So what if our R squared were to get bigger? What do you think would happen to the confidence interval, and what do you think would happen to the prediction interval? So pause the video here and think about how those factors would affect the width of the intervals. So as our sample size gets bigger, our confidence interval gets narrower. And we've seen this in other contexts, that as we get more information, as our standard error gets smaller, that we're able to estimate the mean more precisely. So the confidence interval would get narrower as we get a larger sample size, but the prediction interval actually stays about the same. And if you think about it, the prediction interval is about individuals, right, where the individuals fall. And just because you have a large sample size, that doesn't mean your individuals are somehow getting closer to the regression line, that you have less variability around the line. The individuals still have all of that variability, and so we need our prediction interval to stay wide. So what about R squared? What happens as the R squared increases? So if you just think about it in terms of the shape of this graph, the points are going to get closer to the line as your R squared increases. So as your R squared increases, the points get closer to the line, and it's easier to make predictions when you have less variability, right? So our confidence interval is going to get narrower as r squared gets larger. This time though, the prediction interval also gets narrower. And the reason is because now our individuals are getting closer to the line, right? We have less variability around the line, and so we can have a smaller prediction interval and still capture 95% of those individuals. Also wanted to make some connections to the conditions for inference because both of the examples that we've seen so far in this chapter, there have been some concerns about those conditions. So let's think about the BMI example first. And if you remember from the previous video, with the BMI example, we saw some evidence of non-normality of the residuals, and specifically when we looked at the histogram, it looked like the residuals were a little bit skewed to the right. So if we think about how this plays out with the prediction interval, we end up with many individuals that are above the upper bound. Many individuals above the upper bound of the prediction interval. So we were hoping to capture 95% of the individuals within our prediction interval, but we actually end up seeing a lot of people up here with BMI values that are higher than we would have expected based on their total cholesterol. And it's not sort of even, right? There's way fewer that are below the lower bound. And notice that sample size doesn't fix this, right? Sample size doesn't fix the prediction interval because the prediction interval is just about individuals. So having a large sample size is not going to magically make the individuals normally distributed. On the other hand, the confidence interval is probably okay. And the reason for that is that we've seen that sampling distributions get more bell-shaped as the sample size increases. And that's really what's affecting our confidence interval, where we're trying to estimate the mean value for a particular x. So with a large sample size like we have here, I'm not really worried about the confidence interval, but the prediction interval is more of an issue. And what about the house prices example? That's the one where we were a little bit worried about some possible non-constant variance. So the spread being different for different levels of x. The problem with that is that the intervals that we've made here, the confidence interval and the prediction interval, they both assume that you have the same level of spread for high and low values. Same level of spread for high and low values. Whether you're estimating the mean or the individuals, these intervals assume that we have the same spread on the low end and on the high end. It does dip in a little bit towards the middle, but on each side of the means, we're assuming that we have the same spread. So if that doesn't actually match the data, if we actually have way less spread, say on the low end than the high end, then those intervals aren't really accurate. And one more thing, let me show you how to add the confidence interval and the prediction interval to the graph in JUMP. So this is the BMI example, so I've already done analyze fit y by x here. I think I want to change the marker size. With the dots so big, it's sort of hard to see what's going on. So if I right click on one of those dots, I have a chance to change the marker. So I'm just going to make this a dot for each one since our sample size is so large. Okay, and then to add the confidence interval and the prediction interval, I'm going to go down here where it says linear fit. And I have the confidence curves for the fit and the individual. Where it says confidence curves fit, that's for the regression line. So that is the confidence interval. That's the small one. And then where it says confidence curves individual, that's for the prediction interval. That's the wide one. We can also change this up a little bit. Instead of having the dotted lines, if we wanted to have shaded areas, we can come down here where it says confidence shaded for fit and individual. So like if I did for individual, that would have my whole prediction interval shaded. So you've got some options there.